Alright, I've been experimenting with various inline plug options for equipment that I'm restoring. If I want to be able to disconnect wires, for example, that are soldered directly to a circuit board, there's no plug. I don't want to have to desolder it every time. I found these on Amazon from some sort of nameless Chinese company. These are basically insulation piercing types, and they're possibly available with different numbers of pins, but the only ones I found were the 3-pin ones. And they're loosely advertised as being good for automotive applications, but this particular model is only good for 2 or 3 AWG sizes or gauges close to 22 gauge, so like maybe 22 to 26 gauge or 24 gauge, and I would mostly use 22 gauge on most of these vintage electronic things like this one I'm restoring here. So I decided to try them out. The first thing I did is I put in just strand or solid wire, 22 gauge solid wire, and this is an example of that. It went together pretty well. I tugged on it really hard and I couldn't budge the wires. I rang them out and they were reading, 0.00 ohms, so they seemed to have a good connection. I connected them up with alligator clips to the ends of the wires on both ends and wiggled them around vigorously every which way and couldn't see any interruption in the continuity. So I think they probably work pretty well. I'm always suspicious of these insulation piercing type connections. Even though they work, I'm not sure how robust they are over the long term and with other variables. Here's the Amazon listing for that. It calls it the Bright 4 pluggable low voltage wire connectors, no stripping. They're for 3 wires and they're 2-way, and they're geared for things like LEDs and so on. But they should work for a number of applications. They're rating it as 20 to 22 gauge AWG. This particular variant on it costs essentially $13 for a pack of 24 connectors, and because there is no male and female are the same, so 24 would get you a total of 12 connector pairs. They offer something similar here. This is just for 2 wires, but otherwise the same design. And they have this one that's, again, similar, a little different, the way the clear part is hinged. It still says 20 to 22 gauge, but it's single wire. And then they have these, the description isn't changing here. If you even go over here, it still says 3 wire up here, so kind of a sloppy listing. But if you go over here, they've got the ones where you can clamp onto a single wire and then bring in an additional wire and join it with that. So a T-splice, essentially. Again, they're all insulation piercing. That technology's been around for decades, and it does work. I normally don't see it in electronic applications. It's more automotive stuff. But automotive is actually a pretty rough environment, and it seems to work reasonably well in those environments. So I think I may actually try it out on this restoration I'm doing and give it a try in a real application. The product that I got does not come with any instructions. You have to pretty much use what's on the Amazon listing here. It shows, you know, no soldering. I'm not sure what that picture indicates. I guess no twisting required. No tape. And they show it's 24 pieces making 12 pairs. And there's some instructions here. You insert the wires into the metal slots at one end of the connector, but that's not a correct description. You don't put the wire directly into the slots. If you did, the plastic cover would never close because the wire wouldn't be in those holes in the clear part. So you actually have to put it through the holes in the clear part, and then so it lays over the metal slots. And then you close the clear plastic cap, and it says use pliers to secure the connection. They should say squeeze it shut firmly. Do the same steps on the other connector, and then plug the two together. And here they have more details on wire compatibility. They're saying again 22 gauge to 20 gauge AWG, solid wire, same size for stranded wire. And then they say flexible wire, so by that I think they just mean high strand count wire, which is what I used in my little experiment here. It was high strand count 22 gauge test lead wire with silicone insulation. It's also 22 to 20 AWG, regardless of solid, low strand count or high strand count. I suspect that I read some comments before I bought, and people said the wires just fell out and it was junk. As I showed in my experiment here, if you don't lift the plastic, the clear plastic part up high enough, when you insert the wires in, they won't go as far in as they need to go. So you really do need to raise it up to a higher angle, allowing the wires to go in all the way before you start pushing down and closing the apparatus. I'm going to demonstrate here how this goes together as best as I can. I have another one here that I'm going to use as a sacrificial, and I'm going to put stranded wire into it this time. The first thing that has to happen is to lift up this clear shroud. It's hinged right here where my thumbnail is. The plastic actually just bends. It flexes a little bit there, so you have to lift up this end of it here, and at first it'll act like it doesn't want to do it, but you have to make it rise up. So it'll be raised up kind of like that, and then you insert the wires through those holes so they're going down diagonally. They're not going into the actual, you can see the brass colored bits there. Those are the insulation piercing areas. So the plastic part that's clear here with the holes is what's going to hold the wires while you push them down into the piercing area. So you push them in as far as they go. You can kind of see that. And then without letting them fall out, and it is best to kind of hold them up like this to discourage the wires from falling out. And then you use a pliers, one like that, a small set of channel locks or something, and squeeze it. But I found that while they're held vertically like this, to squeeze them down, then they already get into the piercing area, and they're less likely to fall out when you switch over to the pliers. You got the pliers on there. You give it a squeeze, and there's a couple little plastic latches that click into place when it's fully closed. You can kind of hear them do it. And there it is with the cover closed. Well, I screwed the first attempt up. I didn't actually have that clear part lifted up high enough, so the insulated wire did not go in far enough. Now it seems to be in there a little better. I'm going to try it again. Okay, let's see if second time is the charm. Pulling pretty hard on that blue wire. Pulling on the red. Pulling on the black. They seem to be in there this time. So this is actually two of those connectors plugged together. There's no male or female on them. They're just designed so they plug into each other. I'm going to unplug the remnants of the old one here. Like that. And you can see that there's little metal fingers in there. Maybe not as well as I would like, but they're symmetrical. So you start plugging them together like that, and then push them together until it clicks. Now I'm going to try a continuity check. Okay, I have my ohm meter connected up to the black wires. And this time I'm getting 2.2 ohms. I'm just pulling on the black ones here from both ends, and it's sitting around 2 ohms. Moving over to the reds, pulling on the reds every which way, sitting there at 2 ohms. Pulling on the blues pretty firmly, wiggling them around. It's holding, and again 2 ohms. But with the alligator clips clipped together, it's still reading about 2 ohms, so that's not in the connection, that's just in the test leads and what have you. So it seems to have made a fairly good connection. And again, you can just you have to grab them real firmly and kind of wiggle them apart, but they do come apart. And reconnect. That's all.